Let's see how this goes for a spring. How do I want to put my spring? How about, what the heck, we'll make a vertical spring. Okay, so here's the spring, and it's suspended from a fixed point, and I'm going to pull down from equilibrium. And I want to know how much work do I do in pulling it down. So can you set up the integral, please, for the work that's done in stretching the spring? He asks, are we assuming that the spring is massless? I love this question. If you wish to assume that your spring has mass, go for it.
Let's do it.
Do it. You swashbuckler, you. There's some subtleties associated with massive springs, but they're fun to think about. We'll ignore that for the moment. Okay, so I want to know what's the work done in stretching the spring to an elongation x. So I guess I need to worry about coordinates, or do I? I'm taking x positive down. What's the direction of f? F is up, right? So d work is equal to kx up. Okay. Just kidding. How about minus x hat? And the displacement is going to be down in the positive dx direction. So that's dotted into x hat dx. And this is the answer to the question of whose work? Whose work? The spring's work? You're working. I find that highly suspicious, Jessica. All right, so far, which force here are we talking about? Are we talking about the force the hand might supply to stretch the spring, or are we talking about the force the spring supplies to the hand? Spring, right? So this expression is the force of the spring and if we integrate from 0 to x, from 0 to some final amount of work, we get the work done by the spring is minus 1/2 k x squared. What does that mean, that the work is negative?
The work is done toward the negative.
Right. The spring isn't going to do this of its own volition. We're going to have to supply at each point along the way a force that's opposite to what the spring supplies. So that force is going to have to grow in proportion as we've stretched the spring. And the spring's work done is negative. That's the sign that that energy got stored as elastic energy. So that's in the spring potential energy. If I attach to a mass, I let it go, then I can convert that to kinetic energy. Okay.